Hey all, this might be the first video you're watching, but for me, this is the fifth one that I've done today. It's been a few hours now, and I may be getting a little loopy, so bear with me. Blah, 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 blah. Sorry. All right, last thing we're doing is calculating the sample size needed for a 95% confidence interval. This is example 2 in the examples. Calculate for a 90% confidence interval for the mean of a distribution with a standard deviation of 2.5 and a margin of error of 2. So this one's looking for the mean, all right, which if you've watched the other 4 videos, if I remember what I said in them, I think I said the first step would be to figure out the type of problem. All right, let's do that. Let's figure out the type of problem. So for the type of problem we're doing here, step 1, the type of problem is, why is it so small? The sample mean. All right, let's bump up the jam here. All right, so this is a sample mean problem. We know that because it says for the mean of a distribution. It doesn't say a proportion. Notice it doesn't give us a mean. So to find the n, the sample size, you don't need the mean for this one. So let's go to part 2. This is in our notes. If I didn't show you this, if you're in our shared drive, probability statistics, confidence intervals, and we're looking at calculation, move that for you, sample size. Notes right here, calculation sample size. So it's just a table, and basically it just gives you the pieces that you need. Notice if the sample size is less than 30, we usually use a t, but to pick a t, it depends on n, and we don't know n. So if the sample size is less than 30, we can't do this. So basically we're talking about anything using the z distribution for a sample size greater than 30. Less than or equal to. So this is only for finding sample sizes larger than 30, and we're only using the z. So basically we're doing the same thing. We're going to find our z, but we have some different pieces here. So I'm going to take this, and you guys can do this too. I'm going to take this and put this over on my problem. So whenever you're doing a problem, if you want, you can just grab it from the notes. And then I'm going to take this part. I'm going to copy it and paste it. And then I'm just going to fill in what I put here. I don't know why I did that, but I don't have to do everything. All right, so this is saying I need z times the standard over the margin of error squared. So we should multiply everything. So z you find in the confidence chart. So let's go back to, here's my problem, at 95%. So remember where we can find that. We go to, classwork. We go to distributions, and I want the confidence intervals for z. Open that up to the bottom. For 95%, it's one, see here, critical values, level of confidence, 1.96. So my z is equal to 1.96. And I'm just going to replace that right here. S, what is S? That's your old standard. You're going to find this up here. Your old standard is 2.5. Good old standard. So it's going to be 1.96 times 2.5. I put that in the wrong spot. Hopefully I'm paying attention. I'm a little tired. All right, let's try it again. So let's go with 2.5. And M is your margin of error, or ME. Yeah, it's your margin of error. And we want a margin of error of 2. So now we get our handy dandy calculator, who I like to call my Bob, my friend Bob here. I'm just going to do what it tells me to do. 1.96, 1.96, or 1.96 times 2. Oh, sorry. That's not what it told me to do. This is what you should not do. Clear that. It's 1.96 times 2.5 divided by 2. And then we want to square that. Which just says we only need 6 people for this. We're saying to get a margin of error of 2, n equals. But that cuts us into the t chart, which because the z and the t are different values, you might want to go up to about 30 if we want to do this. You could use the t chart. It will give you a bigger margin of error if we use the t chart because that's a bigger value. If you look up where n equals 6 on the t chart, you're going to get something bigger than 1.96, and that will give you a bigger margin of error. If we go to classwork and see, all right, so let's say we want to use n equals 6. What happens is it changes your z value to 2.571 instead of using 1.96. And that's the problem. You cannot do this type of problem because n is less than 30. So if you ever get anything less than 30, then I would just make it equal to 30. And then you should be okay. All right, that should be fine. So I would say n equals 6 is too small. So we will use n equals, let's do 30. But this is how you would get it. We got 6. And I'm saying because that gets us into the T chart area, it's too small. So let's get us up to the Z chart area. Let's bring it, bump it up. Actually, let's make it 31. I'll make it the Z chart. 30 would still be a T chart. All right, so you do this one.